Moment is best learned by knowing the actual meaning of it and by relating it to the real life situation. It is not by remembering the formula. Moment is caused by force, therefore it is called moment of force. It tells you about the amount of turning effect given by the force. A big turning effect will make the object rotate more easily. For example, in this case, if the man applies a big turning effect on the door will open more easily. Another word for moment of force is torque. In short, we write it as moment. But moment is not equal to momentum. The very important concept is bigger moment implies bigger turning effect and bigger torque. And it will make the object rotate more easily. By definition, moment of force is the product of the force and the perpendicular distance from the line of actions of the force to the point of pivot. Perpendicular distance, line of actions, and the pivot. It is very important to note that for any turning to happen, it must be made about a point. This point is called the pivot. In this case, it is here. Or about an axis, which is called the rotating axis. For the case of the turning of this spanner, it is happening like this. When the spanner experiences a force from the hand, it is going to turn about the pivot this way. At which point should I apply the force in order to open the door more easily? A or B? Your personal experience would have told you that it is better to apply the force at point B in order to open the door more easily. But why is that so? The door can open more easily. It must be due to the fact that it has experienced a bigger turning effect. But why is that so? Can we use the concept of moment to explain all this? Just a quick recap. Moment of force is the product of force and the perpendicular distance from the line of action of the force to the point of pivot. Which means if you have a bigger perpendicular distance, you would have a bigger moment and hence a bigger turning effect. Therefore, in order to give a bigger turning effect to the door so that I can open it more easily, I will apply the same force at point B. This is because if I were to apply the force at point B, it's going to give me a bigger perpendicular distance in comparison to the point at A, which is only giving me a perpendicular distance of this length. So with a bigger perpendicular distance, I'm going to have a bigger turning effect and I will open the door more easily. Bigger moment comes about because of bigger perpendicular distance. In this case, it is this distance from the pivot to the line of actions of the force. Not this distance. It is not perpendicular to the line of action of force. The pivot is at the hinge, and the door will rotate about this hinge. The door will open this way. You wouldn't want to turn the spanner as indicated in the left diagram because the distance between the pivot and the force is very small and it gives you a smaller moment. The nut cannot be released easily because you provide only a small turning effect. Can you release the nut if you insist on turning the spanner at the same point? Of course you can, but at the expense of applying a big force if you have enough muscle. However, for the case on the right, because of the bigger perpendicular distance, a big moment is possible and hence a bigger turning effect. You can release the nut easily and even with a smaller force. For this case of a platform being attached to a hinge as shown, what is the moment given by the force of 50 Newton? To compute the moment, we must know where the point of pivot is, which is this point here, the perpendicular distance, which is this distance, and the line of action, which is this line here. The perpendicular distance, if you know your maths well, should be 0.4 sine 60, and the moment is force times this distance, which is 50 times 0.4 sine 60. What are the forces causing moment about a pivot? Indicate the forces and their respective perpendicular distances. Think about it. There must be one at the CG of this rod, which is the weight, downward, and the other one provided by the spring, the tension on the rod in this direction. More precisely, it is as shown in this diagram here. The perpendicular distance from the pivot to the weight is this one, whereas the perpendicular distance from the pivot to the tension is this. If this table length were to topple, where is the most likely point of turning? Here or here or here? How would it topple? This way? Why is that so? The lamp head is too heavy? If you analyze the various forces acting on the various parts of the lamp, you will have a good idea why the rotation was like that just now. The lamp head has a weight, upper arm has a weight, and these two forces provide the anti-clockwise moment about the pivot at this point. The weight of the lower arm and the weight of the base will provide the clockwise moment about the pivot at the same point. If the anti-clockwise moment is more than the clockwise moment, you will have a rotation as mentioned earlier. Moment of force plays an important role here in deciding what the load a donkey can carry. Donkey does not know the concept of moment, but a human being should. For this load shown here, the weights act somewhere around the center of gravity here. And this weight produces an anti-clockwise moment about the pivot, which is at this point. The weight of the donkey and some other parts of the cart will contribute to the clockwise moment here about the pivot at this point too. As long as the clockwise moment is bigger than the anti-clockwise moment, the cart and the donkey is safe. Note when the load is this big and the force is further away from the pivot. The perpendicular distance is now this big. The poor donkey may not understand moment, but a responsible human should.